Welcome back to Home Theater Gurus. This is episode 11. So, lately we've been going over subwoofers and modal behavior in a room. So now we're going to take it up a step and we're going to look at room modes. And we're going to be using a room mode calculator. I'm going to show you how to use that calculator to easily place your seats and your subs. Now this is going to be for more, for the guys that are using maybe a converted bedroom, or you have a dedicated space, or even a living room, as long as you have all the walls are parallel, like a rectangular or square room. Something where it's not open to like a kitchen. Now you can still use these calculators between any two parallel surfaces. So even if the back is open, you can still use it somewhat to calculate between the two side walls, or if the roof roof is level and not slanted, or cathedral or something like that, you can use the calculator for that too. Okay, so first, what are room modes? Okay, and what do they do? So if you think about an SPL meter, it means sound pressure level. That's what we're reading, is sound pressure. So when frequencies get big enough, they have so much pressure, they actually pressurize the room. The upper frequencies, they don't really pressurize the room. I mean, they're bouncing off the walls. But when you get into the modal, below 300 hertz, it depends on the size of the room, how big the frequencies are in relation to the room. But at some point, they're going to become modal. And that's, you can tell, because when you walk around the room, you'll hear some spots where the bass is considerably louder than others. And, a few steps over, you have no bass at all. And those are room modes. And they're very predictable, and they're called standing waves, and it's just resonating frequencies between two parallel surfaces. Now you also have them bouncing around at different angles, but those aren't going to be the strongest of the ones that are going to be in the room. We don't calculate those and place seating with those. We just use the ones that are parallel, because those are the really, really strong ones, and the ones that we can easily predict. So the room modes are also called axial modes, or at least the ones between parallel surfaces. And you're going to have, you're going to have some between your side walls, you're going to have some between your front wall and rear wall, and you're going to have some from the ceiling to the floor. So that's 3 axial modes, or 3 different axes that they will exist on as long as those surfaces are parallel. Now the calculator we're going to be using today is by Harmon, and the Harmon room mode calculator is the best one I've seen, because it actually places the room. I mean, you can see where the null is exactly in the room, and you can actually see the energy, and like the where the peaks are going to be, and where to place the seats. I mean, it's just it's drawn out for you so well. It's like it takes all the guesswork out of it. Just a really awesome calculator. So basically, we're going to go over the first 4 harmonics, or standing waves, that are going to be in the room next, and those are going to be the strongest ones. But here on my screen here, I've got the first 2 modes. Okay, these are called standing waves because they don't move. In our room, they're stationary. So in this room, if at any time this room is 20 feet long, by the way, and that's what we're looking at, the front of the room to the back of the room. So front wall and the rear wall here, we have 20 feet. So our first mode right here, our first order harmonic, has a mode at 28 hertz. And you can see right here the energy, right here we've got a lot of energy. This is close to a wall. And this is, you've heard that if you're close to a boundary, all the room modes are excited and they're at their peaks. So right here, you see there's a lot of extra bass at 28 hertz. And as you come down, you get closer to the middle, you lose it. And at 28 hertz, right in the middle of the room, you've lost that output. It's going to be down 15, 20 dB. It's going to be a black hole for that frequency. And then as you move out of it, it comes back up. And I mean, you can actually walk, or if you had a meter in this room and you played a 28 hertz tone, you would hear it very loud, get quieter and quieter, boom, nothing. And then you would walk back out of it and it would get louder again. Now our second order harmonic is at 57 hertz. Now this one, it's a smaller frequency. Okay, now the second harmonic, whatever frequency fits in between those 2 walls perfectly, that's what it's going to resonate at. So the second harmonic, like here's a cycle, one complete cycle, and if you were to get a frequency calculator, or to see like the length of a specific frequency, and you wanted to know what frequency is 20 foot long, because this is a 20 foot long room example we're looking at, it's 57 hertz. Now if you had a 30 foot room, it wouldn't be 57 hertz, it would be lower. I don't know, I'd have to get a calculator, it might be 40 hertz. But in this case, one cycle is 57 hertz, and that's where that second harmonic is going to resonate at. And it's going to happen at the 1/4 and 3/4 spots in the room. And then you've got a third harmonic that's going to have 3 nulls in the room, and it's going to be at the 1/6, the 1/2, and 5/6. I'm not going to draw those on here. We're going to see them in a minute in the Harmon room mode calculator. And also you've got a fourth order with 4 nulls at 1/8, 3/8, 5/8, and 7/8. But once you get really into the third and fourth order, you're getting into above the subs. You know, usually it depends on the size of the room. So those are going to be the ones to avoid. These are going to be the ones we can usually fix, the first and second order. So, and the same thing with this 57 hertz, like before. If you played a 57 hertz tone, it's going to resonate in that room. And if you walked across, you would have lots of bass here by the wall, and boom, you would lose it a quarter into the room. Half point in the room, you would hear another, maximum output again. And then you walked out of it. When you got to 3/4 of the room, you would lose it again. And as you walk back to the rear wall, it would pick up again. Okay, so these first 2 modes are the ones we can usually fix with subwoofers, or we can fix with subwoofers. So let's look at how we would fix this. So here we have one subwoofer. So let's say we want it to sit 3/4 of the way back. For whatever reason, that's where we have to sit. Well, we can fix it with a single subwoofer, okay? Now, if we put the sub here, it's not going to do anything. At 57 hertz, we're going to get this black line. But if we were to take this subwoofer and put it here at the 1/4 point, now where that null would be, we would create extra output, and we would force that null up. You're getting up. You're going to force it up. And when you do that, you're going to force it up over here too. So you fixed that null. Now you could put the sub over here too. Of course, that's right there where you're sitting. Maybe you don't want it there. Either of these points will work. Now if you had 2 subs, now you remember last episode we talked about virtual subs. So say you had a sub in the corner, you had another sub, you could place that sub right here at the half point. That creates a virtual sub right here, and you get the exact same thing. You force that null up. You're not going to allow it to exist. So you fix that 57 hertz null. Now you can sit there. All right. Now, remember, this is front to back. You could also look at this and say this is the front of the room, and this is the left side, and this is the right side. Now, let's see, if that room was 16 feet wide, I print mine out, the Harmon's calculator that we're going to be looking at. I always print it out because it's very valuable information. So let's say this is the front wall and it's 16 foot wide. The first harmonic is going to be 35 hertz, and the second one is going to be 71 hertz. So if we were sitting dead in the middle, we would have a null, and that's usually like the sweet spot where everybody wants to sit. Well, you definitely don't want a null in the middle of your room. Remember, this is the front. We're looking at this. Here's the front wall. But our seat is also in the middle of the room. So this is going from the front of the room to the back of the room. Right down the middle of that room, there's a null all the way down those 2 parallel walls. Well, we could place a sub right in the middle again, force it up. Or, if you remember last episode, and I think even the one before that, we talked about the Harmon studies and recommended sub placement and virtual subs. If we place a sub in each corner, look what we've done. We've put a virtual sub here and forced that null back up. We've gotten rid of this null. So now we can sit in the middle. But look what happens on the front wall if we put it at 1/4 and 3/4. Okay, now we've fixed the nulls right here for the second order harmonics, but we've also put a virtual sub in the middle and fixed this one too. So that's why a lot of times you see people recommending putting subs on the front wall at 1/4 and 3/4, and also on the back wall, because that creates a virtual sub in the middle of the room, and it's going to boost that null up and fix these 2 nulls. Okay, now if this is your room and you're looking down on your room, this might be a little easier to make sense here. If we were to put a sub at 1/4 and 3/4 on the front and back wall, we have, created a virtual sub here in the middle, and that's how we got rid of all of these nulls, but we've also created a virtual sub right here in the middle of the room. So not only have we fixed the nulls going this way, Remember, when we put a sub at a null, we know that there's also a big null, the first order null, is sitting right here at the center of the room. Because now we have a virtual sub in the middle of the room, we've also fixed this null too. So all of these nulls, all of these room modes running through the room, we fixed. So we've made the area larger that we can have good bass. So that's all we're doing, is we're trying to make it larger because we're going to have to avoid some nulls. So we need to fix as many as we can so we can avoid the ones we can't fix above the subs. So hopefully that's going to make sense. Okay, now if this is a 10-foot room right here at the middle, we're going to have, you know, our first order null cutting through the room this way, and it's going to be at 57 Hertz. Now, the smaller the room or the smaller the distance between the two parallel walls, the room modes are going to be closer together, because you're still going to have just as many. They're just packed closer together, and that's not really a good thing. So it can be a little trickier to get the head just right so you're out of the nulls that can't be fixed with subwoofers, because, you know, usually like an 8-foot ceiling, most of the issues are going to be above the subs. So like in this 10-foot one right here, 10-foot height, this is going to be the only one that's in the subwoofer region. So now if we did have a null that was at head level but was in the sub region, we could just lift our subs up to the same height as that null where our head is, and we could fix the null, you know, quick and easy. So, but because most of them are going to be above the subs, you know, you just have to look at the calculator and try to, and hopefully you're going to be okay as far as staying out of them. So like at 10 foot right here, at 30 inches, we have a null at 113 Hertz. But the next null is going to be at almost 4 feet. So if you're 3 to 4, about 3 feet, you're going to be okay. You know, but if you go down 6 inches, you're going to hit a null. If you go up, you know, a foot or 3/4 of a foot, actually, you're going to hit another null. So it can get really tricky when you're messing with smaller rooms or smaller dimensions, like if you only have 8 feet right here, or even 10 feet. That's what I was just reading off of. 10 foot's even kind of tight. It's just something to be aware of, and it's another reason, like whenever we're doing the sub measurements, it's really important to have that mic right where the ears are going to go, because, you know, 8 inches down, like at chest level, there could be some major issues there that aren't where your ears are. It's because those modes are being packed so tightly between two surfaces, or two parallel surfaces, that just aren't that far apart. Alright, so let's go ahead and get the laptop fired up, and let's look at that room mode calculator from Harmon. I'm going to show you all how to get it, where to get it at, and how to use it real quick, and we'll talk about it and just look at a specific room and see where we could place our seats and see where we could put our subs to fix some of the issues, and just see where that takes us. Alright, so the first thing we're going to do is we're going to go to Google, and you're going to look for Harmon Room Mode Calculator. Now, we'll also have a link to this in the description, so you can just look down there and get it. So we're going to click on the link. It's going to bring us to this page right here. Now, we're going to click on this Room Mode Calculator XLS. Now, this is going to be an Excel file, so you will need it to open the program. If you don't have it, try to find someone that's got it. You only need to do this once for your room. Print it out and then keep it. You're not going to have to look at this again. This is just something you just want to keep it with you. You know, you're not going to have to come back to this site or, you know, use this calculator again once you've done your room or printed it out. Alright, so we're clicking on it. It's going to download. Okay, so the first thing we need to do is hit Enable Editing. Now, see, this looks really similar to what we went over on the board. So that's why, you know, I really like this program here, or this Excel sheet. It's kind of hard to see, so we're going to go ahead and go to View, and you're going to hit the Zoom button, and let's go ahead and go to 200. Alright, there we go. Alright, so first we're going to enter a room. See, it's got an 8-foot ceiling. Let's set our width for 14 and 0 inches. Okay, and our length, let's say 18 feet long. Okay, so say it's like a nice size bedroom we've converted. Alright, so here we go. Now you can see here's the length of our room. And there's 0 feet up to 18 feet. That's where this back wall is at 18 feet. And down here at the bottom, it tells you exactly where each mode is located or where the nulls are located and what the frequency is. Now this is what we want to avoid or fix, these spots here. So if you notice, our first order mode lands right here in the middle at 31 hertz. And here's our second order, this black mode, and it's 63 hertz, and it's going to be at 1/4 and 3/4 of the room, so 4.5 feet and 13.5 feet back. That's where our nulls are located. And you can also see by our boundaries, that's where all of the modes are going to be excited, or you're going to have, the most bloated or excessive bass. And you can see they're all peaking at these walls here. And if you were to walk through this room, you would hear all of these different frequencies peaking and null, 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 and between them more bass. So you would actually hear this in your room, which is pretty cool. That you could play a tone at either 94 hertz, and you could walk through the room and you could hear it dropping out at these points on this room mode calculator. So anyway, let's say we want to place 2 rows of seats in here, and let's look at our frequencies. This yellow one right here, it's above the sub region at 126 hertz, so we're going to avoid that one. This red one right here, it's at 94 hertz. Now LFE's up to 120, so we could fix it and sit there, but it's still, if we cross our to our subs, or from sub to main at say 80 hertz, it's still going to affect our mains. It's going to be above the subs when we cross them over, so let's go ahead and avoid that one too. Now we could cross over a little higher and fix it with the subs if we had to. That's not a problem. So, but now we would be kind of close to that back wall. Say this is 18 feet. We want to be at least 4 feet away from the wall if we can, just to give if we have rears, give them room to image well. So we don't really want to sit here at 15. Now this one right here, we could easily fix this one. If we fix this mode at 63 hertz, and its nulls are at 1/4 and 3/4 in the room, we have all this area we can sit. It opens up a really large gap of good sound. And all we'd have to do is place a sub at the 1/4 point, and remember that would force this null up, and it would do the same thing over here. And it would basically fix that null, that room mode null. So we could place our seats here at 13 feet. Anywhere, this is 11.25, so anywhere between 12.5 to 14 feet is fair game. So we've got a pretty good area right here we could sit. Now, so let's say we wanted to go ahead and do that. If we wanted to place another row, our second row, if they're large theater chairs, we need, say, 6 feet of distance. So let's say this one's at 13, so that's 7 feet. Let's look at what happens 7 feet up. Ooh, see this one right here at 126 hertz. We've got a null right there. That's above the sub, so we don't want to sit there. Now, let's see, 8 feet. We could sit there at 8 feet, and we'd be right. Let's see, 8 feet would be about here. 7.5 to 8 feet. Anywhere up in here, we'd be good to go. So we could place another row there. And we've got some room if we needed to. Say we placed them at 7.5 feet, but we want 6 feet between rows, between our heads. So if we go 7.5 and 6, what's that, 13.5 feet back? Oh, well, perfect. So having all this room right here that we've opened up by fixing this null is going to really help us, because we can scoot these chairs around and still be in good sound. Where this one over here is a little bit tighter and we don't have as much room to play with. So we could go ahead and do that. We could place our seats at 13.5 or 7.5 feet and go 13.5 feet for the second row. Now we're looking at the width of the room, and a lot of our room modes are above the subs, or they're a lot higher in frequency, and that's because our two parallel surfaces where they're these frequencies are resonating, it's closer together, it's a smaller distance, so that's going to drive the frequencies up. So smaller the room, the more difficult it is. You're working with higher frequencies and they're closer together, so it's harder to place your seating. So you see this one's 161, 121. Those are going to be above the subs, can't really do much with those. This one right here is at 81 hertz. Now this one, if we crossed our subs, say, at 100 hertz, that would be okay. We could do that and fix these nulls here, and they're definitely going to be below the 120 hertz at the LFE range. But if you look here in the middle, where everybody wants to sit in the middle of the room, especially in a room that's not very wide, that's not a good thing, because the first order mode is at 40 hertz. Now we could fix that with pretty easily with subs, but the red one is 121, and that's our third order mode, and that one we can't fix, not with subs. It's above the subs, above where we want to cross to, our mains to subs. So really we need to stay out of this area. We don't want to sit there. So, but this room is 16 feet wide, so we could put 4 seats in here easily. So we're not going to sit in the middle. We're going to go with 4 seats. So we're going to have a head. Say we're going to have a head right here at maybe 6 feet. Then another one, at 8 feet. So these are just going to miss this 161 hertz null, but they're going to be okay. And then our outer seats, they're going to be in problem areas because we've got nulls here and here. But that's going to be fixable with the subs because it's well below our 120 hertz. And we can say cross our subs at 100 hertz and fix it for everything in the room. So we'll completely be able to fix it. But we're just going to have to raise our crossover point a little bit. So this, as long as the subs aren't going to be localized, say with a 100 hertz crossover, you can't tell where the subs, where the subs are located in the room. There's nothing wrong with that, because if you remember from previous episodes, we also have a better seat-to-seat consistency when our multiple subs are handling the frequencies. And this is why, for one thing, we're fixing these modes. So we want our subs to handle as much as they can before they become localized. So we're going to go ahead and boost our crossovers up to 100 hertz, and we're going to fix that. But remember, we also have to fix a spot here too at the quarter along the length of the room. So we've got a sub. Let's say we have one sub sitting here at the 1/4 spot in the room to fix that room mode, because we're sitting at 13 feet back. Well, looking from back to front, that sub is right here. But we need to fix a mode right here. Sure, we could place a sub here right in the middle of the front wall, but you remember we have a sub right here at the 1/4 spot, and we could put a virtual sub out in the middle of the room if we did that. And that's what we're going to need to do. We need to get a virtual sub in the middle of the room that is 1/4 of the way back, but also 1/4 along the front wall. So all we need to do is place our subs at those 2 points. If we place a sub 1/4 of the way from, let's say, left to right, looking at the front wall, we place a sub right there at the 1/4 spot, and we place another sub along. So here's the front of our room, here's the back of our room. If we place our second sub at the 1/4 spot, our sub is now going to be out in the middle of the room, and it's going to be cutting through both of these nulls, and it's going to fix both of them. And we're going to draw that on the board here in a minute, just to kind of give you a little bit more visual that makes sense. So we can virtually place the subs there, and that's going to fix those 2 nulls. And then the height, of course, the height is only 8-foot ceiling, so these modes are going to be really close together. Usually we're sitting at 30 inches off the ground to 3 feet off the ground. And see, we're going to have some issues there, because at 2 feet we've got 141 hertz null. At 3 foot we've got a 283 hertz null. So if we were sitting now at 30 inches, that would be perfect. Now if you notice, I know my chairs, when I recline, I'm sitting about 29 to 30 inches off the floor. That's where my ears are, which is perfect. But this is also another reason when you're taking measurements, I said to put your mic at ear level. You're weaving in and out of these nulls in these room modes because the ceiling to floor distance is not that great compared to other dimensions in the room. So you need to measure where the ears are going to be. And also, if you have risers, you need to use this information to keep your ears from being placed in a mode. Now you can fix some of these modes, like here at 71 hertz. This is in the subwoofer region. If you were sitting at 4 foot off the ground, all you would have to do is, when you're placing your subs along the side wall and the front wall, place them at ear height, and you will fix this mode right here. If you place them at 2 feet, if this was in the subwoofer range, which it's not, you would fix this mode. So remember, when we place a sub add a mode, we fix it. So, but again, at 4 feet, we wouldn't fix this 212 hertz mode, but at least we'd fix one of them. So, but we're not sitting at 4 feet. Hopefully we're sitting at 30 inches, and that would work out perfect. Alright, so let's go ahead and go back to the board, and we'll look at this situation right here where we're going to fix both of these 1/4 modes, 1/4 of the length, and we've got another one 1/4 of the width. Okay, so now to go back to what we looked at on the room mode calculator with the 1/4 and 3/4, modes that we need to fix in both the length and the width. I've drawn it out here. This is what we were looking at when we were looking at the length of the room mode calculator. Of course, it was looking at it sideways. Now we're looking at it above. And here's these little green spots or green circles. These are the heads. So on the back wall, remember we were sitting at 3/4 of the way back, like 12 and a half feet. This was our 18-foot long room. So you remember we had, everyone was sitting right there on a mode which we needed to fix. But then we had these outer heads were also on another mode that we needed to fix on the width. If you remember the width section of the room mode calculator. Now these guys here, they didn't have any modes cutting through the room this way, but they still had, these here. They were being affected by that too. So, and this of course is the front that's looking down. That's our speakers. What we need to do is we need a virtual sub right here, because we need a sub that's going to be on this room mode right here to get rid of this one, which when we get rid of that one, remember it's also going to get rid of this one, and we need to get rid of this one, and when we get rid of this one, we're also going to get rid of that one, because if you remember, those room modes are cutting through the room, like this. So whenever we fix this one and bring it up by putting a sub here, we're going to fix it at all of its dips or all of its nulls. So all we have to do is come 1/4 along the front wall and 1/4 along the side wall, and boom, now we have a virtual sub right there where we need it. So, and if you look at it, we could have done the same thing in the back of the room or on that side or the back here. And anyway, so now all of these room modes are fixed and are now places that people can sit and we can get good bass. And that's going to avoid the room modes above the subs that really we don't want to sit in because we can't fix them with subs. Now as far as bass traps and corner traps go, things like that, if you notice the articles that refer tell you that they treat subwoofer region, they're 20 years old. We don't do that anymore. They don't do well at all in the subwoofer region. The dips and nulls that are in there, or that you see on these examples where they've used bass traps, they're not even fixing them. They're barely softening the nulls. Yes, they make it a little bit better, but not nearly what we can do with multiple subs properly set up. They're stuck in the past, so you just need to understand you don't need bass traps all around your room to get good bass. You don't see these in high-end design rooms, professionally designed. You don't see bass traps all around the room because they're not needed. We know how to place the seats and place the subs, to avoid the need for such a thing. And like I said, absorption doesn't even do well in the bass frequency. It barely does anything. Now, it can be very effective above, once you get 150, 200 hertz, and it really becomes effective. So if you did have to sit, in a mode you couldn't fix, you could use bass absorption. And, in the corners, where those room modes have the most energy, we can treat those corners and tri corners and things like that. So you've got a front wall that, it's like a fake wall with all your speakers behind it. There's nothing wrong with going in there and just packing all the corners and stuff with fluffy insulation. Use as bass traps. Nothing wrong with them. They're definitely not a negative, but you don't want corner traps in your living room because some video or some article 20, 25 years old told you you needed them and showed you some response. One thing that's really funny is they'll show their response against a single sub. If they showed, what they achieved versus what's done today, multiple subs. Again, here's my response at several seats, or across 3 seats, just 4 or 5 measurements. they're not showing that. They're showing it against the worst possible outcome, and then their frequency response looks like trash, really. I mean, it's still, they barely fixed the dips, and yes, the decay is a little better, but we fixed our decay with EQ. Anyway, just don't get sucked into that you need corner traps. You don't, unless you do. You could need one at 150 hertz, 200 hertz. You could have a null that you have to sit in, and then that would be when you would say, okay, I need to, think about some corner traps or some absorption or some tune traps. Tune traps are actually, much more effective, and they can be effective in the sub-region too. Now again, this is just one suggestion, that's what we decided would be a good setup for the room we looked at, in the room mode calculator. There's a lot of other popular options we've already gone over, 1/4 and 3/4, a sub in every corner, opposing corners, that creates a virtual sub in the middle. It just depends on the room and where you need to sit, how many rows you're trying to get in there, and things like that. The thing is, we're trying to fix the issues we can, so it gives us more options to sit so we can avoid the issues we can't fix. That's it, basically. The modal region can play havoc, on your outcome or your sound that you hear. So if you don't know where to sit or you don't understand how to read the room mode calculators, it can be a real headache trying to get good sound. And another thing, if say your rear row is on the back wall, you saw how all of those room modes are excited back there. And your other seat just threw in a room, it may have some nulls in it or something like that. I mean, no matter what, if this back seat is on a wall, all of the room modes are excited. There is no way you're going to have similar sound in both rows. It's not going to happen because you've got a seat or a row where all room modes are excited because they're on the back wall. Then you've got another row, and even if this other row, say, has no modal issues, you've avoided all the nulls. You did a great job there when you avoided them. This other row is being excited at every room mode, so it's not going to sound anything like this front row. So when you start trying to, say you're trying to get a good seat to seat consistency and you can't get it, it's just not happening. If this row is on the back wall, just give up. You're going to have to say, okay, this is the row right here where I'm going to have to give priority. This is the one that's going to get good sound. This one's just not going to sound alike. Because when we're replacing multiple seats, you saw in the room mode calculator how we're looking at that and manipulating them. We're trying to get the same or a similar sound of both rows. So you have to keep that in mind. And if you had to sit on a back row, these would be just like the in-law seats is what they're called. Put that front row, that one's going to get priority. That's going to be where you're going to sit. The back row, you just have to understand it's not going to sound the same. And, live with it. It's okay as long as you're not sitting there. But it's priorities, and sometimes you can make both rows, get them both sounding the same because you can properly place both of them. Sometimes you can't, and if you can't, that's okay. I mean, no one should come at you and tell you, oh, you screwed it all up or anything like that. As long as you understand, the negative impact it has, then that's cool. Nothing wrong with it. Well, like I said, as long as you don't sit there. All right, now one big thing that we need to keep in mind is the spacing of the mains. Now, if you remember from episode 1, we want those mains to be 60 degrees apart. Now, if you remember, if we pull a string from the center of this baffle to the center of that baffle, we find the middle of it, we need to take the distance from our seat and multiply the distance from that point, that string, to our head times 1.15, and our mains need to be spread that far apart, and that's going to give us our 60 degrees. So, hopefully this row right here, we've achieved that. If we haven't, I should have brought that up when I was doing the room mode calculator. We may need to scoot these seats forward a little bit and hopefully, try to miss the room modes, but still, because we still want that big sound. We want that room filling sound, and we want our mains spread where they're supposed to be. We want that 60 degree separation. So that's also going to come into play, and where you're sitting is also going to, that's the seat, your row is going to be the one that you want to have the 60 degree spacing. So there's going to be compromises you're going to have to make, but you want to make sure that where you're at is going to have the best sound, everything is perfect. So we get our seating determined by those two things. Trying to make sure that we can get our main spacing right and avoid the room modes. So, it's kind of a give and take. You got to look at both of those aspects. So now that we've got our seats properly placed, it's going to get us into the next episode, which is going to be screen size and viewing angles. THX has a recommended viewing angle, so we're going to cover that. Now, it's just a recommendation. I mean, I really think it should be like a minimum. I like it a little bit bigger. than what they recommend, but going smaller really kind of takes away from that immersiveness. So we're going to cover that, and that's going to be episode 12. It's going to be it for this one, guys. I'll see y'all next time.